what lasts a long time finally becomes good. And that's also the case for RADAR4Chem. And as task area lead of task area 3, repositories in NFDI4Chem, I have, of course, been following the development of repositories for research data in the field of chemistry with great interest. And since the start of our initiative, and I must say we are already very well positioned here with our selected repositories. And some flagship repositories such as Chemotion were already well ahead of their time, I would say, when NFDI4Chem was launched. They worked on implementing the FAIR principles early on. Other repositories are currently being further developed or even newly built, all with the goal of building a federation of repositories covering the most important areas of chemistry with a focus on molecules and reactions, and making it easy for the chemistry community to publish their research data in a fair way. And I think we are on a very good path with this. However, our analysis have also shown that there are still areas, or let's say scientific workflows, that are not well covered by the existing discipline-specific solutions. And these additional needs include, for example, additional data types, such as measurement data or similar, which cannot be published in the chemistry-specific repositories until now, due to their data format, for example, and possibly also due to their data size, or also due to the content-related orientation they might have, but which can nevertheless contain important information in order to make the underlying scientific work comprehensible and reproducible, or also reusable for others. And these are the main goals of the NFDI. And in these cases, a generically oriented repository such as RADAR can make an important contribution, as we think. And RADAR is a repository specifically for research data and was developed with and for the scientific community. And we now developed RADAR4Chem based on this service RADAR, which has been in productive operation at FIZ Karlsruhe since 2017. And with RADAR4Chem now, we want to make it particularly easy for chemists to get started in research data management by minimizing the barriers to entry and offering data publication free of charge. And we want to complement and connect the existing solutions, of course. For example, we have already been working on a connection of the Chemotion ELN to RADAR4Chem via the RADAR API. And Sonja already mentioned it. I moved from KIT to FIZ Karlsruhe at the beginning of this year, and I'm now heading the research data department there. And I'm very proud that my new team also includes Kerstin Soltau, the product manager of RADAR, and now, of course, also RADAR4Chem, who will now present the new repository and its possibilities, and will also give a small live demo afterwards. And if you want to use RADAR4Chem, you can just contact Kerstin or me. And with that, I'll hand over to Kerstin.
Yes, thank you, Felix, and thank you, Sonja, and so on, for having the opportunity to introduce RADAR4Chem to you today. As Felix already said, RADAR4Chem is based on our longer existing RADAR service, which is a generic, cross-disciplinary research data repository. RADAR, in fact, it stands as acronym for Research Data Repository itself. It's used for the archival and publication of research data from completed scientific studies and projects, and it was developed in a DFG project over the period of 3 years and has been operated as hosted all-in-one cloud service by FIZ Karlsruhe since 2017, as Felix already said. RADAR's target groups are, so far, publicly funded higher education institutions and non-university research institutions in Germany. These institutions, they sign a service contract with us and they pay their usage on a yearly basis, and the bill, their cost, these include basic fees and usage dependent fees based on the storage volume used for the archival and publication of data. But by using radars, these institutions have the advantage that they do not need any own technical infrastructure for the data storage and data publication in their institution, as the keyword all-in-one cloud service implies. RADAR is operated with the participation of various academic institutions. FIZ Karlsruhe is the provider and the contractual partner for the customers, for the institutions, and the complete IT infrastructure itself is located in the computer centers of the KIT, where 2 copies of the research data are stored, and a 3rd copy of the data is stored at the TU Dresden. Further, RADAR cooperates with the TIP Hannover as data site member for the registration of the persistent identifiers, the DOIs. With RADAR4Chem, we now offer, based on RADAR, a publication service, especially for research data for the chemistry committee, for research data from all disciplines of chemistry. The target audience of RADAR4Chem are, contrary to RADAR service, the researchers themselves. That means regardless of their academic home institution. As for RADAR, the operator of RADAR4Chem is again FIZ Karlsruhe, but the special things here are that for RADAR4Chem, RADAR's computing centers at the KIT Karlsruhe and the TU Dresden, they provide 3 terabyte of storage volume for the publication of research data from the chemistry community, free of charge, as their own contribution within the framework of NFDI4Chem. And FIZ Karlsruhe takes over the DOI registration fees for the researchers. That means by this operating model, there are, to our minds, 2 groups of winners for when we use and introduce RADAR4Chem. First, of course, the researchers themselves, since they can use RADAR as an established, reliable, comprehensive, and easy to use publication service for all kinds of data formats and disciplines. And however, especially RADAR4Chem is a low threshold to use service, not only in the aspects of ease of use, but also in other aspects. For example, researchers, they do not have to sign a service contract with FIZ Karlsruhe. Instead, they accept our or agree to our RADAR4Chem license terms of use as soon as they upload data for the first time. And the offering is completely free of charge for researchers from the 4Chem chemistry community. There are no publication and no usage fees to pay. And in addition, the chemistry community, of course, also has a benefit, since RADAR4Chem, it provides access to published research data in accordance with the FAIR principles, as I will explain later in more detail, and thus contributes to the improved availability, sustainable preservation, and independent publication capability of research data. And to maximize this benefit for the 4Chem community, we do not offer or do not allow data archiving functions within RADAR4Chem, but only data publication function as RADAR4Chem's core function. This slide, it lists all those RADAR4Chem core functions and features. Of course, the core function is the data publication for all data types and formats. And for each published data set, we guarantee a retention period of at least 25 years. And over this period of time, we ensure bitstream preservation of the data. Each published data set receives a DOI, which is then registered with DataCite. Optionally, users can reserve DOIs in advance before the publication. Optionally, they can delay the publication by an embargo period up to 1 year. And optionally, they can also make use of an external peer review step before the publication. The RADAR metadata schema is based on the DataCite metadata schema. And I want to emphasize now that, for example, prior to each publication, a license must be chosen, for example, a Creative Commons license that uses the reuse of the data set, and further a RADAR publication can be linked to other digital resources via the metadata field related identifier. After a publication, the metadata, they are automatically indexed in various formats and offered for public harvesting, for example, via our own FITS-CALSO OIA provider, so that dissemination and discoverability of the data set and the metadata are ensured. And last but not least, metrics on access and download figures are available on the RADAR landing page as well. Have a look at the metadata annotation. A data set cannot, it can be annotated at different levels, not only at the level of a data set, but also at the level of individual folders, subfolders, and individual files. Annotations can be done via an editor form, via XML uploads manually, or even via a RADAR API. Our metadata schema is, as we said, generic in nature and based on the DataCite kernel. It has 10 mandatory fields, and in addition, there are 13 optional elements, which we will see during the live demonstration. RADAR often uses controlled vocabularies for selected metadata fields, and the system has interfaces to, for example, to the ORCID registry, to the Crossref Funder registry, to OpenStreetMap. And currently we are working on an interface with research organization registry to facilitate, for example, the entries of publishers, rights holders, affiliation information. Yes, since recently, we also support subject-specific metadata schemes, which can be defined by the user himself. The disadvantage of this feature is that we do not yet support this via a metadata editor, but this should be enhanced in the future. And the system also supports FAIR principles, as the next slide explains. With various measures and features, RADAR promotes the implementation of the FAIR principles as quasi-standard. And this screenshot, it shows a table, which we have also published on our website, which lists then these individual measures and features. For example, the criteria interoperability We support, since RADAR allows, for example, automatic exchanges via standardized XML files. It uses persistent identifiers as often as possible, and we support references of other electronic resources, as I already said. So please feel yourself invited to have a look at this table after this talk. And here, this slide shows the radar system architecture and the architecture of the software and the infrastructure itself. This is divided into 3 different layers, which communicate with each other via this red interfaces here. The top layer is, of course, the user interface, the front end, the graphical user interface, for example, which we will get to know during the demonstration. Below, we have the management layer, our back end. Here's everything located which has to do with authentication and authorization, metadata management, and so on. And at the bottom, we have the storage layer. That means the archive, the tape storages here from the KIT Karlsruhe and the TU Dresden data centers. This is here connected to store the research data within RADAR. And in this graphic, you also see here this temporary storage in connection with this term ingest service. And this refers to the data transfer within RADAR. And this is in fact done in 2 steps, which is also reflected in the RADAR workflow for users to upload and publish data. The first step is, in the first step, the data is uploaded into this temporary, so-called temporary storage. This is used for editing, for organization of the data, and for metadata annotation. Data can be transferred either as individual files or as complete containers, zip or tar archives, for example. In the temporary storage, the data has the so-called states pending or in review, and data integrity is ensured by the calculation of checksums upon the upload procedure. The temporary storage itself is a redundant disk system with a daily backup. The second step is when publishing, then, or when archiving, but in RADAR4Chem when publishing, then the data is transferred to the archive as permanent storage. Thereby, the data set is then packed as a tar archive, and as soon as the data is in status published as packed archive, no more editing is possible. The dataset archive uses the Beckett standard. It is self-contained and self-describing. That means all necessary information is contained within this tar file. This file includes the research data, including the complete file and folder structure, also all related descriptive and technical metadata, and some other information such as manifest and checksum. Again, in this second step, RADAR ensures data integrity by the calculation of checksum, which are then also included in the metadata itself. And data security is ensured by data redundancy. As I said, we have 3 copies at 3 locations. And further, every 5 until 8 years about, the data is migrated to new tape storages at the 2 or 3, at those 2 or 3 locations in the partnering data centers. Yes, what are the use cases for publishing research data from chemistry in RADAR4Chem? As we said, all types of data and formats can be published and stored in RADAR4Chem. Of course, we know that there are already various subject repositories for individual data types in chemistry, which are also contributing to the NFDI4Chem, for example, as core repositories. And we do not want to be any competitor to this subject repository, but RADAR4Chem, we want to complement this portfolio of already existing repositories. Possible data publications suitable for RADAR4Chem are, for example, data sets which do not fit in any of the already existing subject-specific repositories. Data sets rather from interdisciplinary research, or so-called distributed data sets that do not fit into one single established repository due to its diversity of data types. And then these data sets can be linked to each other via related identifiers, for example, in the metadata. Regarding the practical workflows, how do chemists get in touch with RADAR4Chem and with FIZ Karlsruhe? There are not yet, there will be contact forms, for example, on the NFDI4Chem, and of course the RADAR websites. And scientists can use these forms to contact us at FIZ Karlsruhe, and scientists should inform us about the person, their home institution, the subject, the discipline they're working on, the research project, and also the research data set, for example, the size, number of individual files, file formats, and so on. And we at FIZ Karlsruhe, we advise the user, we check whether the researcher can use RADAR4Chem and is also entitled to use RADAR4Chem, because at the beginning of the service, we only offer this service to researchers in Germany. Maybe we widen this, or we hope to widen this up at a future time, but this restriction has to be respected at the beginning. In case the user is entitled to use RADAR4Chem, then we are setting up a separate workspace for each requesting user in the RADAR4Chem environment and authorize the user as data provider in this workspace. And currently, this storage volume per workspace is limited to a maximum of 10 gigabytes at the beginning. And this is my last slide here. This graphic shows the RADAR4Chem roles and rights concept. Here, I said, we at FIZ Karlsruhe, we are the administrator for the RADAR4Chem environment. We set up these workspaces individually for each researcher in which he can organize and publish the data, and we assign and authorize researchers with the role as data provider, the so-called curator role in the RADAR vocabulary. And as curator, the researcher then logs into the system. And for logging in, there are two authentication options available in RADAR. Either with a RADAR account after the user has registered online locally to the service. And next to this, RADAR also supports Shibboleth. So it can be used via DFN AAI. This is the authorization and authentication infrastructure of the German Forschungsnetzwerk, so that he can use RADAR with his home institutional account. When logging in, the user is then automatically taken to his or her workspace, where he or she uploads the research data, organizes the data, annotates the data with metadata, and then maybe optionally has triggers a peer review step, and finally publish the data set so that at the end, everybody from outside, without having a RADAR account, can access, view, and download both data and metadata. And this was the theoretical part of my presentation. In the live demo now, I would like to show you how researchers can act as data providers and upload and annotate, publish data, but also as appetizer. I would like to show you an example of a data set already from the biochemical research already in the system. This is the portal here in the header. You can toggle from English to German language, and you can log in on this, and you can search for data sets here. And here we have the publication list of the individual data sets, and by clicking this link, you are then linked to an individual landing page of this very data set. And I would like to show you at first this data set from the Leibniz Institute of Plant Biochemistry in Halle, which they published over 2 years ago. And this landing page, it offers at the top here the title of the data set. And in the right navigation frame here, you see the DOI number, you see the publication date. Here you have via this button the option to download the data set, then as this tar archive. The size of the data set is also given on this button. Here you have access to the metadata via this drop-down menu. You can download the metadata in different schema export formats. The landing page also has raw statistic data, the right statement, also linked to, if available, to the appropriate page at Creative Commons, for example. And here you have also an option or a suggestion how to cite this data set. And in the central screen of the data set, we have, or everybody has access to the metadata, to the content statistics and technical data, metadata. And the RADAR metadata shows all metadata that data provider has entered, not only the mandatory, but also the optional parameters. So the landing pages of individual data sets, they vary from each other within in aspects of the scope. For example, in this data set, the researchers, they entered some alternate identifiers, gene bank, CAS registry numbers, INCI keys, and so on, related to this research project. In the related identifier field, the researcher has the option to link to related online publications for this data set. For example, here, this information says that this data set is the supplement to this journal article here, which is immediately linked from the landing page here. Further, we have creator, author, and contributor information. The size of list may vary depending on the data set. We have the personal information, the affiliation information, and also this field also offers the direct linking option to the appropriate ORCID profile. And for the contributors, there's also the information about the role within, and the type of contributional role within this research project here. Then we have title information again, keywords can be entered. The subject areas are indicated. Not only one subject area, but several subject areas can be indicated. Here we have information about the data source. This is a biochemical research on paper, nichrome, for example. We have the information about the software used for the data and the resource processing, including the software name and the name of an alternative software. We have, of course, rights holder information, and here is optional information, the information about the funding organization, including some project details linked from this landing page as well here to the DFG website, for example. And on the content tab, we have in this data set, we see that this research data set is really organized into a real directory structure. We have NMR data, we have kinetics data, we have modeling data here, and we can also here navigate deeper within this content tab, and we see here the different data types, for example, included in this data set. Then we have statistics data next to this simple statistics information, also via on a month-by-month basis, and also as a bar chart here available. And we have technical data about the uploading person, date stamps, not again the archive size, and also here is the checksum, the archive checksum in the as hash value given. Yes, this was the short appetizer, how a landing page might look like. And now I changed the sites, and I want to show you how data providers upload and publish the data in the system. And I do this not in the system, but in our test system. The test system, everybody can use this and contact us in case you would like to use this. Then we set up a test account for this appropriate researcher or institution. It's used as a playground for interested parties and for training purposes. Yes, login is done via this login button here. And then you see that these two authentications options I already informed you about. Users can either log into the system via their institution account in case their home institution is participating in the DFN AAI infrastructure. This is, for example, the case for the FITS Karlsruhe. That means the user has to select the home institution from the list, then click proceed, and then he is taken to the login page of the home institution, where he can then enter RADAR with his home institution credentials. I do not use this way now, but I use my special training credentials here. Via my special training RADAR account. Everybody can set up a RADAR account via this self-registration form we have available here online. It's a very easy process to set up a RADAR account here. Yes. I log in with my test credentials, and I'm immediately then taken to the RADAR4Chem test workspace I set up before. This is the personal workspace as entry point for which each data provider in RADAR4Chem would have. And yes, this here I then enter my workspace, and here you can see that within this workspace, a data set can have, as I said on this slide with the two-step data upload process, the data set can have the steps, the states pending, in review, published, and archived. But as I said, archived is not, archiving is not available in RADAR4Chem. Yes. To create a new data set, a researcher clicks the same called button here at the left side. And then for the first time, these license and user instruction for data providers of RADAR4Chem are prompted up, or should be read, and must be accepted for the first time. It roughly explains the scope of the service, gives information about the license, and some sentences about the user instructions. These terms and conditions, they will also be available on the RADAR website, so that you can have a look on it in advance. So I accept these terms and conditions once, and then I enter any dataset name. I just enter some dummy text here. Then I select a file from my local folders here, either via drag and drop or via the file manager. In this case, I use the drag and drop option. Then the system, it automatically recognizes that in this case, I would like to upload an archive, a zip archive, and the system asks me if it should be unpacked during the uploading procedure. I say yes. And here I have in the next step the option to request this data integrity check during the upload procedure. I also say yes here in this case and click upload dataset. Then this dataset is unpacked and loaded into this temporary storage. And you see this zip archive has been unpacked and the content of my zip file is identically available within this data set. I can further navigate deeper here. You see, I always use these traffic signs in my demo, so to become not too discipline specific. So the content of this data set is still open. It's in the temporary open storage and the content can still be changed. More files can be added, folders, subfolders can be created, files can be deleted, renaming can be done, and so on. It's quite flexible. And next to, yes, the content can be changed. And of course, the metadata annotations have to be done. This is done via clicking the Edit Metadata button, and then the metadata editor form opens. And this gives me the option to enter metadata manually here, or to upload a customized XML file on the right top side here. To do so, we have a metadata example file for download available here in this drag and drop box, which you can customize and then upload if it's huge data, or if you would like to upload often data samples which only differ in some certain and few aspects. This is done to facilitate the metadata annotation. Yes, the persistent identifier is of course assigned automatically by the radar system, but in case you would like to reserve a DOI for this very data set in advance, you can, for example, click here, DOI, and then you have this DOI already pre-registered for this very data set. The metadata editor reflects the RADAR metadata schema, which has 10 mandatory fields, and these are available on the left, marked in a bold type with this asterisk, available for direct entry, and the all optional fields are as links here and can be opened by clicking on these links. Yes, at this point, I would like to change and skip to another data set in which I made some annotations in advance. For example, here, it's also in the pending state. Here, for example, I already have made use of this related identifier in which metadata, which gives me the option to link to other digital resources of this data set, and I can specify the type of relation and the type of resource. Then I enter, for example, the URLs or the DOIs of this other electronic resource. In the creator, in the author, and in the contributor field, I enter, for example, the affiliation information here. Here, we will optimize this field, since we will include or integrate RAW here very soon. The ORCID ID of any author and contributor can be easily added by clicking on Find ORCID, and here we have this interface to the ORCID registry. And for example, here, yes, what I wanted to show, yes, we have several additional titles. A script description can be given, several keywords can be entered and also deleted here. These are all searchable. Yes, the subject area also allows to select or enter several different subject lines here. Here, this offers a selection list which is based on the DFG subject classifications list. And if your subject is not available within this DFG subject classification list, you can just select other, and then free text fields comes up. Yes. Here we have also some geolocation information based on the GPS coordinates. As we said, we can specify the software used in the resource processing, production and viewing, and here also give the names and the software use. We can enter additional information about the data source here, and for example here, then select the instrument of this very experiment and so on. The right statement is also available as a controlled list to pick on. We will soon have a metadata schema update and will enlarge the list of available license types in this respect. But already now, via other, you can also enter a proprietary license here at this time. The funding metadata field offers the option to use to use the cross-refunder registry search option. For example, if you click, if you enter here, begin moment. If you begin to enter your term, you can immediately then select from this suggestion list and then also fill in the award number, award URI, and the award title, so that as many project information is available on the landing page here. Yes. After you have made all your annotations, you can validate your metadata. And since I was not very earnest by here, and my validation finished with several errors now, but you see, why happens this? Yeah, I have to, of course, enter anything. I have to erase these optional fields. I have to select a proper license statement, and I have to enter the true rights holder here. I let validate again. In this case, the validation finished without error. Now I'm in a state that I can publish the data set, which I can do now. The review step would be just clicking on the review it button, and then it would have give me the option to copy this link here and to pass this link on to the reviewer. And then he would have, or she would have, access to the radar data site without having the need of without having the need of having a RADAR account to access the data set. And during this time, the data set cannot be edited or further changed. I cancel this review step and now just show you the publication process. I trigger the publication just by click on publish it. The system already gives back that the metadata was successfully validated. It asks me about my email address. It re-asks me, repeats to ask for a second time that this is the proper license I would like to use. The future DOI is already indicated here. And as a last step, here I have the option to specify any embargo period from immediate access, instant access, up to 1 year. So I would not like to delay my data publication. I click publish now, and the publication process has been triggered now, and this might take several minutes, but usually this is quite soon, not within 25 hours as the system said. In general, our system and also the DataCite system is quicker. That means in this moment, the DataCite metadata store then is contacted by the API, and the DOI is registered there, and the metadata of the dataset are automatically released for harvesting, for example, via the Fitzcarraldo OIA service provider, and thus can be found soon on the internet. And soon the dataset is now already in the state publish. Yes, you see, within our test environment, this publication already finished. This dummy DOI is set. The publication state is a date is given, and this would be then the final state of a published data set, which is then also available in, I just log out, within this our publication list as new published data set. This was all from my side now.